So I think this is going to be one of the more important sections that we talk about. Mental calculations, specifically with percents, because percents occur so often in real life. We run into them all the time at the store, in our classes. If we're reading something about the news, statistics, they're everywhere. And again, often when you're viewing things like that, you don't need to get you don't always need to get an exact answer either. Sometimes you just want to get an approximation. So we're going to look at some strategies for doing these types of mental calculations with percentages. And so one way that we will talk about is things we talked about before, compatible numbers. And this is one of my favorites. I use this trick all the time. So compatible numbers. What does that mean again? It means numbers that work well together. And so the first thing we're going to talk about is this. Taking 10% of a number. 10%, I'm just going to make up a number, 10% of 25. When we are taking 10% of a number, let's think about other ways we could do that. We just saw a whole video about taking a percentage of something. And so 10% could be thought of as 10 out of 100, or it could be thought of as the decimal 0.10. And when we're taking a percentage of something, um, uh, again, we could set up proportions and stuff, but what we end up doing is multiplying. And when you multiply by a decimal like 0.1, you get this. We've talked about this before. 0.1 times 25 is 2.5. And so the decimal point in the number 25, when we multiply by 0.1, shifts one spot to the left to get 2.5. Taking 10% of a number is as easy as that. Try 10% of 147. Did you get 14.7? Take the decimal here at the end, one spot to the left. That's it. So how can that be helpful to you? Well, if you have to take some other percentage of a number that you could manipulate 10% with, for example, maybe 5%, 20%, even 15%, any multiple of 10 is going to be really easy. Let me show you how you do it. So let's say you're asked to find 20% of, let's say, 85. Well, you could start with something that you know very easily, 10%. I should have written the word of. Let's start with 10% of 85. Well, that's going to be 8.5, like we just discussed. Well, 20% is twice as big as 10%. And so if we want to know 20%, we can take whatever we had for 10% and double it. 8.5, if we double it, is 17. 8 doubled is 16. A half doubled is 1. Put them together, you get 17. So 20% of 85 is 17. We didn't have to do any calculations. We could do that all up here. Let's try another one. What if we did this a little harder, maybe? We'll see. How about 5% of 40 of 42? 5% of 42. If we start with the baseline of 10%, 10% of 42, start there, and you know that's going to be 4.2. How does 5% compare to 10%? It's half. And so what do you suppose half of 4.2 is? 2.1. So 5% of 42 is 2.1, 2 and 1/10. So that is a really nice trick. We use that a lot if you are going to leave a tip. You know, you go out to dinner and you want to leave a tip and you want to leave 15% or 20% or 25%. That's an easy way to do it, mentally to get, again, an approximation. And this this visual helps show why that is. If we know that 10% is 1/10, one entire column, 5% is half of that. 15% is one column plus half of it. 40% would be 4 columns. And so again, you can, once you know 10%, you can adjust as needed. So let's have you practice a couple of these. Take 15% of 82, 20% of, we'll make it a dollar amount, $31.40. Imagine a 20% tip. And then 25% of 30. We'll make that a dollar amount as well, $30. Pause and try these on your own. The ones with fives and another number can be a little bit, I don't know, they take a little more mental energy to hold all the information in your head. But if you look at the number 82 and you recognize 10% is 8.2, so 10% is 8.2, and you know that the 5% component of 15 would be half of that, 4.1, add those together, and you get 12.3. Add 10% plus 5%, and you're going to get the 15%. So again, that one might be a little more challenging to hold all of these in your head at once, but I challenge you to do it. 20% of $31.40, $31.40. Again, if we take 10%, we're going to shift that decimal one spot to the left to get 3.14. And if we double that, what is that? 6.28, $6.28. 25% of 30. Okay, so first we're going to take 10%. 10% is 3. I'm just going to talk through it without writing it. 10% of 30 is 3. 20% would be 3 doubled, which is 6. And then we have got to add another 5%, which would be half of 3, which is 1.5. We were already up to 6. Now we add on that 1.5 and we get 7.5 or $7.50. Again, if you start with 10% of 30, it's 3. 20% is equal to 6. 5% is half of 10%, so 1.5 or $1.50. And then we want those two added together. That's where we get $7.50. So hopefully you found that a helpful, useful tool if you were not aware of that already. Another thing that can be helpful when you are working with percentages and want to calculate them quickly is knowing their fraction equivalents. So these are 9 common percentages and fractions that I recommend you work to commit to memory because they're very common. They occur in lots of different scenarios, and knowing them as a fraction can sometimes be very helpful to us. Again, just some visuals to go along with this as well. Right, we know 1/10 is 10%, right? We can see 10 sections there. 1/5 is 20%. So if you think about these 20 boxes shaded, there's our 20%. But if we cut our grid up into 5 pieces, that represents one of those 5 pieces. 1, 2, 3, 4, 5, right? So one of those entire pieces out of 5. 1/4 is 25%. Make a 5 by 5 corner here, and you get 1, 2, 3, 4. So 1/4 is 25%. And so you may even say, well, why are we doing that? Well, because of a problem like this. What if you want 25% of 88? You could do this a very long calculation, or if you recognize that 25% is 1/4, and 1/4 of 88 is the same thing as 88 fourths, you're dividing 88 by 4, which is equal to 22. And so recognizing this, again, mentally, if you just say, oh, I know that's 1/4, So I'm going to divide this by 4, divide both numbers by 4, and you get 22. 33 and 1/3% of 45. 33 and 1/3% as a fraction, remember what that was? 1/3. So what's a third of 45? Whatever 45 divided by 3 is. 15. One more. What if we do 75% of 24? See if you can do that mentally. So 75% of 24 is the same thing as 3/4 of 24. And so would be curious to know how you would go about doing that. We know that 3/4 of 24 is the same thing as 3/4 times 24. And if you think about our cancellation techniques that we've learned before, 24 and 4 can cancel to be 6. Think about 24 divided by 4, because this is up top, this is on the bottom. And all we're left with is 3 times 6, which is 18. Perhaps you even thought about it as, all right, I know 3/4 is just going to be a fourth plus a fourth plus a fourth. 1/4 of 26 is 6. Then I have 3 of those to be 18. However you're going to think about that. I purposely designed this question so this number would be divisible by that denominator. So that's just a way you can use fractions to do some of these mental calculations as well. Sometimes we can also do substitutions. We've seen this before in some of our other chapters. Here's an example of when you might want to use a substitution. Remember, this often looks like the distributive property. And in your brain, you might not picture the distributive property. I know I don't, but I do this type of substitution all the time. Let's say you want to take 90% of, I'm going to go with a number like, let's do 140. And you may think, there's no way I could calculate that. Well, 90% is the same thing as 100% minus 10%. That's what we're substituting, right? We're substituting in that particular thought. And so I might then say, all right, well, I know 100% of 140 is 140. And I might know 10% of 140 is 14. Remember the moving the decimal spot? And if I want to know 90%, I would take 100% and subtract 10%. I'd take 140 and subtract 14. And that is 126. So that's a very clever way of doing a calculation like that, involving some substitution. So why don't you try a couple of those? Why don't you try 110% of 430? And also, why don't we do this? It's a little more challenging, 45% of 18. So go ahead and take a moment and try both of those in your head. So again, I'll talk through my thinking on these. 110% is 100 plus 10%. Well, 100% is just the number itself, 430. 10% would be just the 43. So 430 plus 43 is 474. Now, again, it would be 430, 100% minus or plus, let's undo that, plus 10%, which is 43. That's how we're going to end up at 474. This one, did you figure out that 45% is 50% minus 5%? So if we can find 50%, and if we can then find 5%, we can do that subtraction. Well, 50% of 18 is 9. It's half. 5% of 18 would be this 9 And then the decimal moved one spot to the left. 0.9. It's 1/10 of 50%. So 9 minus 9/10 is going to be 8.1, 8 and 1/10. So that one was certainly a little more challenging. But maybe you are seeing that now. So again, some strategies for using those substitutions when you're doing percentage calculations. So now let's talk a little bit about approximations. Again, approximating means you don't always need the exact number, and we'll use compatible numbers for doing some approximations. So we're going to approximate. Approximate means we're just going to get close enough. And so one way you might do that is if you have a percentage like 47% or 52% or 48%, those are all pretty close to 50%, right? Those are pretty close. We kind of like round off the numbers we start with. Similarly, if you get something like 34% or 35%, you could say those are pretty close to 33.33%, which is the same as 1/3. 50% is 1/2. And these are easy fractions to work with sometimes. So those are some strategies for using compatible numbers when doing approximating. Sometimes you need to replace both numbers that you're working with. For example, if you're asked to find, or you just need to out in the real world say, oh, I need to know approximately what 24% of $18.75 is. Well, you could say, I know that 24% is really close to 25%, and that's really close to 1/4, or that is 1/4. And then $18.75 is pretty close to 20. It's fairly close to $20. And then you're left with 20 divided by 4, which you can do in your head to make 5. It's close, right? It's, again, an approximation. Okay, so this would be approximately $5. And again, all we care about is, can we get somewhat close? Get it to a nice, neat percentage that I can change to a nice, neat fraction, and then I can do my division or whatever else I need to do from there. So why don't you try a couple of these? Go ahead and try 34% of 62.4 and 47% of $87.62. So again, there's not always a perfect way to do these, as long as you're using the strategy of doing an approximation and demonstrating that you're attempting it like that. As I said before, 34% is pretty close to 33%, 33.33%, which is equal to 1/3 of. And now I'm going to look for a number that's divisible by 3. 62.4 is really close to 60. And I can take 1/3 of 60 to get 20. So we are pretty close there, right? Again, it's not the only way to do it, but I think that is a one option. Maybe you even on this one went to 63. Maybe you rounded that to 63. That would be appropriate too. For this one, I would say that's pretty close to 50. So 47 is pretty close to 50, which is 1/2. And then we're taking half of, we could go to 88 here. That's a pretty easy number to take half of, which would be $44, right? So that's how we might approach that one. And then the last thing we'll look at here is doing some approximating when we have to change our percentages, or we take a percentage that's written as a fraction, making it to a compatible fraction. I'll show you what I mean here. So let's say that you are asked to, or maybe you take a test and you get 47 out of 60 questions right on a test. So there's a fraction there, but maybe your grade is going to be stated as a percentage. And so you want to know, what is this approximately as a percent? Again, if you're just looking to get close, um, manipulating these numbers so they are easily reducible into a fraction that we know. One thing that you might notice is you can do 48 over 60 because both of those numbers are divisible by 6. And once you do that, now it is 8/10. And you should know 8/10 is 80%. So again, very quickly, you can say, I got about an 80% on this test. It might not be exact, right? But I was able to know approximately how well I did there. So let's try this. We'll go three different fractions here. We'll go 16 over 62, and we will go 300 over 2,490, and finally we will go 42 over 87. So adjust the numbers in the fractions so that it's easy to change them into a percentage. And again, you're all going to maybe choose different things here. You could go 16 over 64, but I'm guessing most of you might have gone to something like this, 15 over 60, because 15 times 4 is equal to 60. That means this is equal to 1/4. 15 goes into 60 4 times, so it's 1 over 4, which is approximately 25%. So we would say this is approximately 25%. For this one, this jumps out to me, 300 over 2,400. Just rounding this down a little bit, because I know I can cancel off some zeros there, leaving me with 3 over 24, which is equal to 1/8. And if you recall from above, this is one of those percentages that I recommend you know. It is 12.5%. 1/8 is 12.5%. That's a great one to commit to memory. Finally, this one, 42 over 87. To me, I say that's pretty close to 42 over 84. And I chose that number because it's a half. And so it's going to be about 50%. How you all see these are going to be different. Everybody's going to see these differently. But again, you need to know that these options exist and keep working, keep challenging yourself to try them, even if they are difficult.